What we have here is a schematic or pictorial schematic of the circuit. I'm going to go over some of the components needed and show you what they look like. This is a transistor. This represents a transistor. You have a base, collector, and emitter. The actual component looks like this. It's a 3-pin transistor. You got a base, collector, and emitter. This is an NPN type, and that's what we're using here. The little arrow that's right here dictates the emitter, and whatever, if the arrow is pointing out, it's an NPN transistor. If it's pointing in, it's a PNP transistor. Our next component is going to be the 555 timer, which is the very versatile component. It's been around a long time. This is an 8-pin package. It's called a dip package because you can insert it into a breadboard, which we're going to show you in a moment. It has an indicating spot on here, which is like a little indentation. And off to the left of the indentation is always pin 1. Some packages like this come with a little circle there to tell you pin 1 is at. But if it didn't have that there, it'll always be this pin that's off to the left of this little indentation here. Let's see if you can see that pretty good. I don't know if I can focus that in, but anyway. So, yeah, so it's 8 pins on this, and they start counterclockwise. You got pins 1, 2, 3, 4. Over here is 5, 6, 7, and 8. So it's 8-pin package. Our next component is going to be the LED, or light emitting diode. This little symbol here, this is the cathode side of it, and this is the anode side of it. The cathode side always go to the negative potential, and the anode side always go to the positive potential. And that device looks like this. They come in a variety of colors. They're small voltage packages that require about 1.7 volts to fire or to light up. Anything higher than that probably can destroy this device. On these devices, there's a flat surface area just to one side over one of the pins, and that is your cathode. This side is your flat surface area, so this pin right here will be the cathode. This pin will here be the anode, so you'll be going negative and positive pin. And that's what gives off the light that you see when it's flashing. These little squiggly lines here represent resistors. And in this circuit we have two 1000 ohm resistors, and they should be brown, black, and red in color. Resistors have a color bands on them, like this. And we use these color bands to determine the value of the resistor. And in this case, brown, black, and red, which equals 1000 ohms. The fourth band on here is a tolerance band. This is 5% because its band color is gold. So this is a 1000 ohm resistor. We also have, coming off of pin 3, a 270 ohm resistor, but I'm going to be using a 330 ohm for this resistor instead. So that one would be, the color package on here, or the rings would be orange, orange, brown. That's 330 ohms. And it also has a gold band, so it's 5% tolerance. Also, on this drawing here, I've shown the wiring, which is what these lines are. This is the IC package I showed you before that looks like this, right? But these are the wires, how you connect it all together. This is drawing here stands for a capacitor. This is what stores energy and releases energy quite quickly, depending on what resistance is running through it. Here's a capacitor here. This one has markings on it. The markings on here are 100 microfarads and 25 volts. So it's a 100 microfarad capacitor. It's electrolytic capacitor because it has terminals. It has a positive and a negative lead. Alright, so now let's see what we have here. In this diagram, it shows just how it's wired up. Pins 4 and 8 get connected together, and they go to a positive potential or positive side. Pins 1 will go to ground, so it'd be, you see this wire running here, and it will go to ground. This symbol here stands for grounding. So we know pin 1 will go to ground. As I've drawn it here, when the wire comes up to another wire, if it's not dotted, then it's skipping over the wire. As in this diagram, it just shows you that it's not connected to this wire. These wires are connected because of the dot. The dot shows that these are interconnected. This capacitor, the positive side of the capacitor goes to pin 2. The negative side of the capacitor goes to pin 1. On the pin 3, one side of the 330 ohm resistor will go to pin 3. This says 270, but I'm going to change that to 330 ohms. I found that works a little bit better. So we're going to do 330 ohms, okay? All right. So we use this 330 ohm here and a 330 ohm here. And the reason why is because, as you can see, this resistor leads to the base of this transistor, which is this device. The thing is, you don't want to overdrive this with too much current either. Just like you don't want to overdrive the LED with too much current. That's why I have a 330 ohm resistor running to the anode of this LED, and I have a 330 ohm resistor running to the base of the transistor. Pins 6, 7, and 8 get connected by 2 resistors. The resistor R2 is connected from 6 to pin 7. Resistor R1 is connected between pin 7 and pin 8, and they're connected together here. But the midpoint of this is between 8 and 6. 7 is the midpoint. So let's see what else we need to talk about here. Yeah, so essentially I think that's about all I need to tell you about this. So now we're going to get down to actually putting it together, which is easy. Here we are again. Okay, now we're going to construct this circuit we talked about a moment ago onto something called a breadboard. A breadboard essentially is just a testing board. It's what we use in electronics to prototype circuits before we permanently solder them onto printed circuit boards, which looks like something like this. Once the circuit has been tested and you decide, oh, it really works, then you can put all your parts onto this type of thing and making it more permanent. And you will use solder and a solder iron, of course, to do that. Maybe in a future video I will show you how to solder. But for now we'll be using a prototyping board called a breadboard. And the way this works, The breadboard has, as you see, hundreds of holes here in the ceramic material here. Inside these holes are connecting points. The way this board works is that all these holes that are going this direction are connected together, but they're not connected to this next line. So each line has its own set of wires, we just say. And if you want to connect something here, you can find it at this. It'll be still. If you put a tester on it, you would find it this hole, at this hole, at this hole, and this one here. You won't be able to find it here or here, just in this line only. So whatever's connected in this line is connected all together. All these go together. And what I mean is this. Let's say we take the timer, which we're going to do anyway. I'm just going to go ahead and plug it into the board. We're going to make this a little bit easier. Now, this 555 timer is plugged into the breadboard. Now, pin 1, all the holes from pin 1 stretches all the way out to here. All the pins from pin 2 stretches all the way out to here. Pin 3 stretches all the way out to here. Pin 4 stretches all the way out to here. And so forth for the others. So, if I wanted to connect something to pins 1 and 2, or like pins 1 and 2, I don't have to connect them just here. I can connect it even down here, like I'm going to do here. That LED is now at pins 1 and 2, even if it's this far away from it. Because, like I mentioned, all these holes are connected, are pin 1, all these are pin 2, all these are pin 3, and all these are pin 4. Now, up here, we use these two rows for voltages. Mostly you hook the positive terminal to one side, hook the negative terminal to the other side. So you would never put the positive probe and negative probe in the same line. It's just shorted out. It's like putting the battery terminals together. You don't want to do that. So on this board, I use an indicator color wires to show me which row is positive and which row is negative. Let's see. So we're going to try to hook up. We have the 555 timer connected in. So let's go ahead and connect our first component. We're going to connect the resistor from pins 7 and 8. We're going to connect that 1000 ohm resistor up. And this is a 1000 ohm resistor, so I'm just going to take the pins and I'm going to insert it in rows 7 and 8 and just press it in. Now this resistor is connected to pins 8 and 7. As you see here in the diagram, pins 8 and 7 has got a resistor. Now I'm going to connect another 1000 ohm resistor to pins 6 and 7. And I'm going to use the same value band, brown, black, red. I'm just going to put them on pins 6 and 7, but I got to check something, make sure I'm not messing up here. Yeah. Okay, that's even, yeah. So that should be pin 6. Let me look. 5, 6, yep, 6 and 7. So now we have this part of the circuit connected. It's in there. As it shows here, this is a transistor. We need to find a place to put that. Then we need to find a place to put the connected to the positive and a negative terminal. So we'll take our resistor, which is one of these NPN transistors, and I'm going to place that somewhere on the board. But instead of placing it this first row, I'm going to put it right about here to give me ability to put wires around it. Well, let me see. I'm going to use it, put it in the center. And yeah, sometimes you have to press it in there, but there we go. It's in the board. Now this is your you have your emitter, your base, and collector pins. Everything in this row is for your emitter. Everything in this row is for your base. Everything in this row is for the collector. Also, with that area, you can, as you can see in the diagram, there's a LED with the pins that are connected to base to the E and the collector. So the anode goes to the collector and the cathode goes to the emitter. We're going to connect that now. And that's simply by finding remember there's a flat spot on the LED that is negative. So we're going to connect that to our emitter, so I'm going to flip it around here like this. I'm going to line it up here, and I'm going to fit it in the board some kind of way here. Let me see. You might have to spread the pins just a little bit. Okay, right now, this side of the this pin on the LED is connected to the emitter, and the anode is connected to the collector. So that part of the circuit is in. So that all that this little circle here of stuff is what this is. This LED is connected to the collector and emitter of the circuit. Now we're going to connect a 330 ohm resistor from the positive rail to the collector. And to do that, we're going to take this is a 330 ohm resistor. I'm going to take and I'm going to use a jumper wire this time, because I need to get out the resistor to come from here and from here to here. So I'm going to just insert this resistor here, right by this. I'm going to bend the pin slightly, but yeah, I'm going to put it right there. And then, so actually this pin on top is connected to the collector rail of this transistor. Now the bottom end of this transistor is going nowhere right now, but it's in this slot of holes. The base of the bottom of this resistor is with anything you connect to any one of these, you get connected to the base of the resistor. So we're going to use a jumper wire to go from the positive rail here, and we're going to connect that to the base of the resistor that we just put in. So now this pin has a positive energy through a 330 ohm resistor. Also, the same resistor is protecting this LED from the full potential of this voltage. So this LED is using this resistor also to protect it. So now we're going to, so that's essentially what I mean is this 330 ohm resistor. Let me see if I can see that pretty clear, but I'm trying to show you. Okay, the 330 ohm resistor is now connected to the base, to the anode of the LED, and it's going to the positive rail. And it's going to keep me from sending the whole amount of current to the transistor, collector, or the anode of the LED. Okay, our next connection we're going to make is going to run from the cathode, or the negative part of the LED, and the emitter to the base. To the ground. We're going to get our ground terminal in now. So we're going to take a wire, we're going to run it from the emitter and the cathode and send it to ground. So we will use another jumper wire. I want to use a jumper wire. These jumper wires are pretty handy because they have a area where you can grasp and pull them in and out the board, you know, and the pins are on the end. So anyway, we're going to connect. We're putting one jumper here, and it's just touching the emitter of the transistor and the cathode of the LED. We're going to put that on the negative rail. And remember, I told you this rail, all these in the rail here is positive. All this on this side, this rail is negative. So we're in the negative rail right now. So, and one is in the positive rail. So that's in there. As you can see in this diagram, the emitter and the cathode is going to ground. Okay, so far right now we have all of this. This is all connected in the circuit right now. We're going to move back to the 555 timer and finish completing the timing capacitor and the current limiting resistor from pin 3. But first we're going to connect pins 2 and 6 together, and then pins 4 and 8 together. And I'm going to use some smaller jumper wire like this. I'm going to connect let's see if I can use a tool. I want to connect pins 4 and 8. This is pin 4 and this is pin 8. I'm just going to connect them two together with straight wire. We want straight wire with no resistance in there. And then we're going to connect another piece to pins 2, 1 and 2. So pins 2 gets a wire. Here, I'm going to stick that in the board. These pliers just help me get it in the board a little easier. I don't know why I keep bumping the camera, but hang on just a second. Let me just make an adjustment here. Alright, now bring it in just a little bit closer if I can. And there we go. I think that's right. Bring you back in view. Okay, now, yeah, back where I was hooking pins 2 and 6. Yeah, 2 and 6 together. So you got pins, the holes for pin 5, the hole for pin 6. So we'll put this wire in pin 6, like so. Alright, so what we have here now is pin 8 and 4 are connected. Pins 6 and 2 are connected. So let's proofread this. That's what's indicated here. As you can see, a wire coming from pin 2. That little dot, like I said, means connected. So it continues, jumps over pin 3, goes under pin 4, and goes around to pin 6 and lands there. So that's done. Our next component will be, let's see, I want to get the hard ones out the way first. So we're going to hook a resistor from 330 ohm resistor from pin 3 to the base of the transistor. Okay, let's find, okay, first of all, the base of the transistor is here. So I'm going to take a 330 ohm resistor and I'm going to jump across some wire and leads here. I'm going to show you in a second. I'm just going to send it here instead because I got more room. Sometimes you got to move things around where you got enough room. But anyway, remember I told you all this is pin 3. All these little holes here are connected to pin 3. So one end of the resistor, a 330 ohm resistor, is on pin 3. The other end must connect to the base. It must stretch all the way over here to the base. And for that, I'm going to use a jumper. I'm going to use just any color, don't matter. I'm going to stick it this one. And that's connected to the base of that transistor. And I'm going to send the other end to the to touch, which is the top end of this resistor here. So now this resistor is at the base of this transistor as indicated here. Let me move this over for a minute. I just connected pin 3 via 330 ohm resistor. I sent it all the way around to the base of the transistor. And that's what we have here. Alright, as you can see, the circuit is coming along quite well. Okay, next we have, let's see what we might be missing. Let's see here. Well, so far what we don't have is pin 8 going to positive. Well, I got you in view. Pin 8 going to the positive rail, or pin 1 going to the negative rail. We're going to fix that right now. So we will take a jumper and we will go from pin 8, and I'm just going to send it up to the positive rail, which is there. I'm going to get another jumper, and I'm going to send it from pins 1 to up to the negative rail. So now we have energy, negative energy coming here to pin 1, positive energy going here to pin 8. 4 and 8 is connected, 2 and 6 is connected. Pin 6, 7, 8 is connected using these 1000 ohm resistors. Pin 3, which is our output pin, this is a current limiting resistor of 330 ohms. It's traveling from here all the way over to the base of the transistor to keep, you don't want to put too much current to the base of that transistor there. It would cause it to malfunction if you do. I'm trying to see if I need to make some better spacing on here. I don't know, everything is kind of crowded, but oh well. Yeah, so let's see what else we're missing. Trying to see what it, oh, I know what's missing. This here, we need a capacitor. And a capacitor is used to charge and discharge, or it helps the, okay, we're back. As I was saying, we're going to hook up a capacitor, because we need a timing capacitor to help the circuit to re-trigger itself. So we're going to connect the capacitor between pins 1 and 2. We're going to use a 100 microfarad capacitor like this. This has a negative pin, denoted by that symbol there, negative symbol. That's the negative pin, and of course the other one is positive. So with that, we're going to put the negative on pin 1. So we're just going to just take that and stick it in pin 1 and pin 2 socket right there. And let's give a quick look over. I think that's about it. So now we're going to power it. I'm going to just use today, I'm just going to use this rechargeable, I have a chargeable 18650 rechargeable cell, you know. There's a positive terminal and a negative terminal. I'm going to connect that to this circuit. So first I'm going to hook some jumper leads, negative and one to the positive here, like so. Now we're going to hook if everything goes all right, it should work. If it's not, we'll recheck our circuit. Right now I'm hooking up the negative, and now I'm going to hook up the positive terminal. Just give it some juice. Oh, what do you know? It works. So the 555 timer in astable mode is re-triggering itself to fire the LED. It's using a NPN transistor which can be used to also, just well as this LED flasher, it can also fire a relay of a different power. So if we didn't want to run this circuit just on this battery voltage, I can use a higher voltage as long as I use a transistor or a transistor of higher power. You can switch bigger devices on and off. You don't have to be a little LED like this. It can be any device depending on the current load needed. They have power transistors that are made like, let me see if I have one. I think I do. I'll show you. They have some made in these packages like this. These are capable of handling much bigger loads, much bigger currents and voltages. And as a, same thing, collector, emitter, collector, and collector, base, emitter, whatever. So yeah, it's the same thing, except it's bigger package, so it can handle bigger loads. Well, I hope this has been educational for you today. I hope you've learned something. I'm going to be making a video on in more detail on some of the components, so you can maybe figure out how you would like to use some of the components in your own circuit. I'm going to use this circuit pretty much to flash an LED like within a reflector like this for nighttime use on a bike. So when I'm riding, the LED would flash this in the dark, and it lights up pretty good, pretty bright. That's just one of the ideas I have for using this circuit. You might have an idea for using this circuit of your own. Thanks for watching, and try to subscribe. Bye.